Hi guys, so today we're looking at lesson 4.3, solving quadratic equations by completing the square. So if you remember last time we looked a little bit at factoring quadratic equations. So we had that kind of divided into two different lessons. And today we're kind of going back a little bit to chapter 3. So if you remember, we did look at completing the square in chapter 3, but now we want to extend it into kind of these ideas of quadratic equations and how we can use that method to solve for them. So it's one of those happy times in math where you've learned something and you get to use it again, so you know you didn't learn it for nothing. So let's kind of just do a quick recap of what completing the square is using a very simple and straightforward kind of equation. So we have y is equal to x squared minus 8x plus 5. So if you remember basically what we're doing in here, the first step is we want to isolate the first two terms. So we're going to have x squared minus 8x, and we want to keep them together as a group, and then plus 5 is going to be on the outside. The reason we group those first two terms is so that we can easily identify the term that we want to use to complete our square. So remember, with completing the square, basically what we do is we find half of this value. So half of negative 8 would be negative 4, and then we square it. So negative 4 squared will be 16. So now what we have is x squared minus 8x, and negative 4, half of this squared, is positive 16. So we add 16, but remember, we can never just change an equation without having it balanced out. So if we add 16 into the equation to complete the square, we need to subtract 16 so that we've had a net change of 0 in the equation. And then we add 5 still on the end. Okay, so then the next thing we want to do is just keep the trinomial here, the nice square trinomial, together. So let's isolate that. We're going to have x squared minus 8x plus 16 minus 16 plus 5. Now keep in mind, if you would have had something that you would have factored outside of this square, or outside of this bracket, remember that you would need to multiply it before you move it outside. But because this one was just a value of 1 for our a value, we didn't have to worry about that. Okay, so then the next thing we want to do is basically figure out how can we make this trinomial into a binomial. So remember, that's just two brackets that are like x plus something or x minus something or one of each. And so in order to do that, what we want to know is what is the square root of 16 that adds to make negative 8. So square root of 16 is 4, but if we want to add 4 to make negative 8, it would be negative 4 times negative 4 to make positive 16, negative 4 plus negative 4 to make negative 8. So essentially that tells us that our binomial is x minus 4, because both of the terms need to be negative 4 to make these products. And we can just say that that bracket would be squared. And then we just simplify these two numbers. So if we had negative 16 plus 5, it's going to be negative 11 here. And so there is our factored equation using completing the square. So again, on the filled in notes online, you'll find the written instructions for each one of those steps if you need a bit of a reminder. So some key ideas that we're looking at today is that a lot of quadratic equations can't be solved by factoring. And sometimes graphing functions will not result in exact solutions. So remember, we've kind of talked about this before. The term exact solutions is used a lot, like on tests, they'll ask you for the exact value, and that's what we're talking about here. So with an exact value or an exact solution, what it means is you cannot give a decimal. You either need to have your answer as a fraction or a radical. Okay, so yeah, fraction or radical. And remember, radical is like square root of 7 or something, right? Because if you square root 7, you're going to get a weird decimal number. So if you're asked for an exact value, you can't give that decimal number. You have to just leave it as root 7. Let's see what else. Factoring, graphing, and completing the square are all possible avenues for finding the zeros. So yeah, if factoring and graphing aren't working to give you an exact value when you need it, then completing this square can help you out with that. So let's look at this first example here. It says solve and check for x minus 1 squared minus 49. Now, even though we're looking at completing the square in this lesson, what I want you guys to keep in mind always is all of the different methods. And especially if you think back to lesson 4.2 part 1, we talked about some different formats of equations that you'll see. And if you can recognize those easily, then you will be able to factor more easily. So right away we can see here that we actually only technically have 2 terms. And when we have 2 terms, what we always want to check for is whether or not they are perfect squares. So 49 is a perfect square because it square roots to 7. And x minus 1 is squared, so that's a perfect square because the square root of it is just x minus 1, right? So basically, let's see. Yeah, I think I had this a little bit different in the one that I laid out, but essentially we would say, okay, square root of x minus 1 squared is going to be x minus 1, which we don't actually need brackets for anymore, so I don't know why I drew those in. But and then square root of, doesn't matter so much the negative right now because we just look for the square root of the number 49, which is going to be 7, but because we have a minus there, it's going to be the plus or minus 7, right? Because you could have either one multiplying to make positive 49. So now in our equation, basically what we're saying is, if we want to just solve for our x value, what we've kind of figured out is that x minus 1 plus or minus 7 is equal to 0. So now we have this like set up pretty simply where we actually only have one variable we need to solve for. So what we can do is just use algebra to isolate x. So plus or minus 7 on this side, we can basically bump it over to the other side. So minus 1 means, because it would be either one of these plus or minuses, it's plus or minus on the other side as well. And then now we want to move this 1 away. So because it's minus 1, we want to add it. So x equals 1 plus or minus 7 is our answer. Okay, so that means we have 2 possible roots. X would be 1 plus 7, which would be 8. Or x can be 1 minus 7, which would be negative 6. So those are our 2 possible roots that we've solved for. Okay. All right, let's have a look at this other one. So solve for p squared minus 4p equals 11 by completing the square. And here's where it's telling you to leave it as a simplified radical. The other way that you might see this is exact solution or exact value on a test. So just remember, it's very important that you're aware of these words, because if you do not leave something as an exact solution when you've been asked to on a test, you will have marks taken off. Okay. Okay, so what we have here is p squared minus 4p equals 11. And we want to solve for the p value there. So if you want, what you can do is move this over to equal to 0, but actually because eventually we'll be isolating p, it shouldn't matter too much right now, because what's happening here is almost what we would kind of want to do with completing the square anyways, which is that we want to have our first 2 terms isolated, right? So if I move the 11 over, it's just going to be an extra number there. Now what I want to do with these 2 terms, because I have a p squared and a 4p, is I want to complete this square. Okay, so p squared minus 4p. So in order to complete this square, I need to figure out what's half of 4 would be 2, and then if I square that, it's going to be 4. So it'd be negative 2 here. Squared is positive 4, so plus 4. And then remember, I can't just change my value, so I need to subtract 4 off as well. And that is equal to 11. Okay, then all I need to do is get my trinomial kind of together. So because I don't have an a value out here being multiplied by anything, this 4 can stay the same. If I want, I can in the next step move it over to the other side by adding it to 11, and then I'm left with my trinomial here. P squared minus 4p plus 4 equals 11 plus 4, which is 15. And And then what I want to do is make this into a binomial. So the square root of 4 is 2, and in order for two 2's to add up to -4, they would have to be negative. So my binomial is going to be p minus 2. Because they're both going to be minus 2, I can just square that, and I can say that is equal to 15. Okay, so now what I would need to do is to solve for my actual p-value. I have everything else is a number value except for p, so I want to isolate the p using algebra. So the first thing I need to get rid of is this square. Remember using like your BEDMAS to decide how to isolate p. Square root of p minus 2 squared is going to be equal to, and if I square root one side, I have to square root the other. So now I'm left with, when I square root that, p minus 2 is equal to square root 15. And then I'm going to have to move this 2 away from the p-value to get it, to isolate it. So that means I need to add it to the other side. So basically what I'm going to have is p is equal to, I've added 2 to this side, so it's positive. And then with a square root, remember it's always plus or minus because we can't say for sure. So plus or minus the root of 15. Okay, and that would be our final answer. So when you're being asked to leave something as an exact value or a simplified radical, this would be your solution. Okay, so don't do like square root 15 in your calculator and add it to 2 and then give a decimal. All right, example number 3, a widescreen television has a diagonal measure of 42 inches. So that's usually how, if you're given a measurement for a TV, that's how they're measuring it, is across the diagonal. So you have 42 inches. The width of the screen is 16 inches more than the height. So again, this is one of those nice ones where they've given it to you. Height would be the base value because the width is based on the height plus an additional value. So here we have the width is height plus 16. Okay, and they want us to determine the dimensions of the screen to the nearest tenth of an inch. So in this case, it's a little bit different than what we looked at in the last lesson. Remember in the last lesson we had area, so we could just say this times by this equals the whole area, which was a number value we had. This time the number value we have is this diagonal here. So you need to think about what would be the relationship between two sides and a diagonal. Well, you can see that it basically forms a right triangle, right? Because this is a rectangular shape. And the value that we're given is for the hypotenuse, which is always that really long side. So if you think about that in terms of Pythagoras, we know that a squared plus b squared equals c squared. And so that's what's actually been written out here in formula, in like the formula form. So a squared is h squared plus b squared, so b is h plus 16, and we square that, is equal to c, which is the hypotenuse, 42 inches, squared. Okay, and we basically need to solve for h. So essentially we're given this function and we need to be able to solve for h in it. So how are we going to do that? Well, when you have these kind of like more complex forms than we're used to, usually what I find is the best thing to do is to start out by expanding it and simplifying it. Okay, so we want to get this as simple as possible. So essentially h squared stays as h squared, but we want to take care of this bracket. So what we have is h plus 16 times by h plus 16. And then that's equal to 42 squared, and I'm just going to make that into the number, which is 1764. Okay, now I want to multiply out my brackets using FOIL. So I'm going to keep the h squared plus h times h is h squared, so I have another h squared. H times by 16 is plus 16h. 16 times h is plus 16h. And 16 times 16 is 256. And that's equal to 1764. Okay, so I've expanded it. Now I want to simplify by combining like terms. So I have two h squared values, so it's going to be 2h squared. 16h, I have two h values, so I want to combine those, so plus 32h. And then I have my number value here, plus 256 is equal to 1764. Okay, now what I want to do is set my formula equal to 0. So basically I need to get rid of this 1764 by subtracting it from there and moving it to this side because I want to have a good quadratic function. So it's going to be 2h squared plus 32h plus 256. Oh, whoops. Nope, I'm going to do that math before I write it out so I don't have to waste more space here. So 256 minus 1764, which gives me negative. So let's just put that in. Negative 1508 is equal to 0. Okay, now the last thing I want to do, simplify as much as possible so that I can look at isolating h, which means that because there's an a value other than 1, I want to see if I can get rid of that by dividing it out. So 2 goes into 32 and it goes into 1508, so that's going to work out just fine. So let's put the 2 on the outside and then do h squared plus 32 divided by 2 is 16h, and 1508 divided by 2 is 754, so minus 754, and all that can be set equal to 0. Okay, so now I have this whole setup here, and basically what I want to do is get as close as I can to isolating h. One of the things I can do, because I have this side equal to 0, that's kind of nice. If I do something to both sides of the equation, then it's balanced out, and so I don't have to undo it later on, if you remember. So what I can do is I can get rid of this 2 by dividing this side by 2 and that side by 2. 0 divided by 2 is going to stay 0, but dividing this part out is going to leave me with just h squared plus 16h minus 754, and that is equal to 0. Okay, so now that's a lot easier to work with of a value. So if I have a crazy number like this 754, doesn't seem like it's going to be super easy to figure out numbers that multiply to 754 and add to 16. Of course, you can go ahead and try, but what I would recommend here is completing this square. So with completing this square, I'm going to isolate my first 2 terms, and then I want to find half of this value and square it. So h squared plus 16h, half of positive 16 is positive 8, and if I square positive 8, I get positive 64. If I add 64 in, I need to subtract 64 out. Minus 754 equals 0. Okay, so that would be how it would be. Now what I want to do is make, actually, you know what? I'm just going to skip a step because I'm sure that if you guys are doing this and you're comfortable with it, you're going to start doing the same thing. So because there's nothing out here to multiply this through, I can just put that on the outside of the bracket right away, and that's just going to make it a lot easier. So now what I want to do is make this into a binomial. So remember, I need to find the square root of 64, which is 8, and then I need to decide which kinds of 8s will add up to positive 16. Well, you would have to have 2 positive 8 values there to add to 16. So our binomial is going to be h plus 8, and because it's a perfect square, we can just write it like that. And then negative 64 minus 754 is going to be minus 818, and that's going to be set equal to 0. Okay, so now what do we do? Well, we have our binomial, which is going to be kind of like looking at our roots, but because we have this subtracted value here, we need to move that over to the other side and square root this all to get an exact value. So basically what we would do is say h plus 8 squared is going to be equal to 818. And that doesn't help us out a whole lot for isolating h. So again, what we want to do is we still have this squared bracket. We want to square root both sides. So we're left with h plus 8 is equal to the square root of 818. And remember, whenever you have a square root of a value left, it's always going to be plus minus. Now I want to move this 8 over because it's positive here. I need to subtract it from the other side. So I'm going to say h is equal to negative 8, and then plus or minus the square root of 818. And those are going to be my 2 possible values. Okay, now in this particular one, it tells you to determine the dimensions to the nearest tenth of an inch. So we can actually solve for this one. So you would go in and do, let's see, square root of, try and bump this up a little bit, square root of 818. Okay, gives us 28.6, so we have negative 8 plus this value and negative 8 minus that value. So when we look at these two values, which one would make sense? Well, the negative is not going to make sense as a dimension for a TV. So to the nearest tenth of an inch, 20.6 would be our best answer. So height equals 20.6 inches. And then if we're solving for the width here, I can't remember if they measured it as width or length. Whatever. Anyways, so the width is going to be h plus 16. So 20.6 inches plus 16 gives us a width of 36.6 inches. And so those are our two values. Okay, so that's looking at completing the square. A couple of kind of things we've added on. The initial process of completing the square is the same as what you learned in chapter 3, but basically now what you're moving on to do is once you've completed this square, you have to solve for the variable a lot of the times in these types of questions. And so when you're solving for the variable, just remember that if you get this nice perfect square binomial, then you want to move the number value over to the other side and then square root both of them. And especially if you need to leave it as an exact value, you can do that. Once you have your exact value form, though, if you need to give a decimal answer, then you can do that mathematically. And just remembering to pick the one that makes sense, so not the negative in this case. Okay, so you have an assignment to give a try for that will use some of these skills, and next time we're going to do a little bit more work on completing this square. So we're basically going to extend this lesson in the next one. So I will see you then.